In this video, we are going to prove that for all real numbers x and y that are larger than 1, x squared over y minus 1 plus y squared over x minus 1 is larger than or equal to 8. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. The key to prove this inequality is to first prove an easier one, which is that for the left side of the given inequality is always larger than or equal to x squared over x minus 1 plus y squared over y minus 1. The motivation of doing this is that if this claim is true, then I can continue with the proof by dealing with each fraction separately, because there is no overlapping in the unknowns between these two fractions. So let's see if this claim really works. To prove this, I'm going to regroup the fractions within the inequality according to the denominator, x minus 1 and y minus 1. So it's actually equivalent to proving x squared minus y squared over y minus 1, the fractions in blue, is larger than or equal to x squared minus y squared over x minus 1, the fractions underlined by red. Next, I'm going to move x squared minus y squared over x minus 1 to the other side. So we have x squared minus y squared over y minus 1 minus x squared minus y squared over x minus 1 is always larger than or equal to 0. Next is also equivalent to taking out x squared minus y squared. And the difference of the two fractions will now be x minus 1 minus y minus 1 over the product. Simplifying, for the numerator, we have x squared minus y squared times x minus y. And we can factorize the numerator further, and we have x minus y all squared multiplied by x plus y over x minus 1 times y minus 1. Now at this point, notice that the perfect squared x minus y all squared is always non-negative. And for x plus y, because x and y are both larger than 1, so the sum is always positive as well. Whereas for x minus 1 times y minus 1, under this condition, they are both positive as well. So all parts highlighted in green are positive, or at least non-negative, so the product will never be negative. And so we have the claim. Now that we have the claim, we can take a look at each fraction. The first one is x squared over x minus 1. In fact, I'm going to show that it's always larger than or equal to 4. And we can do the same for the other fraction, and so our inequality will be proven. Now indeed, the difference between the fraction and 4 is exactly x squared minus 4x plus 4 over x minus 1. We have a perfect square at the top and a positive number at the bottom, so it must be non-negative. So this fraction is really always larger than or equal to 4. And similarly, that also works for y. So therefore, we have the required inequality. The left side is always larger than the version with the unknowns rearranged, and each is at least 4. And so we've proven the required inequality. Please feel free to share ideas in the comments. Thank you for watching. See you next time.